have the same position in x at this catastrophic moment. So what now is the distance between the monkey and the golf ball, the distance between the two trajectories, one trajectory no gravity, the other with gravity. This distance equals 1/2 gt2 squared for that same reason. And we all know that if the monkey at time t equals 0 let go, that in t2 seconds it will have fallen exactly over a distance 1/2 gt2 squared. Exactly. This couldn't be more tragic. And he will be killed. You may say, well, yeah, but you have manipulated the speed of that gun just so nicely. Oh no. Oh no. I can shoot that with a higher speed at the same angle alpha, and the trajectory would be this, and the monkey would be killed there. I can do it with a lower speed, and the monkey would be killed here. It's independent of the speed of the bullet. Because always this part here is always exactly the distance that the monkey falls in that time. However, if the speed is very low, that it hits the ground before the monkey hits the ground, well, okay, then the monkey is safe. So the only thing that is very, very critical is alpha. It must be precisely aimed at the monkey. If that's not the case, then the monkey will be safe. Now, before we will witness this classic and rather tragic drama, I want to look at this from a somewhat different point of view, namely from the point of view of the monkey. The monkey sits there, looks at the gun, and the golf ball comes to the monkey. And I will put them both in a room, which is an elevator, and the elevator is in free fall, and they don't even know that. They both fall with the acceleration g. Here is the monkey, 3, and here is the gun. The velocity of that bullet is v0. And so the monkey will see that bullet come straight at him. There's no such thing as an arc. They both fall in this falling elevator, and so the bullet comes. The monkey happens to be a very intelligent monkey. And the monkey says to himself, how long do I have to live? And the monkey makes the following calculation. If this distance is d, and this is h, then the monkey says, aha, this is the square root of d squared plus h squared. So from the monkey point of view, the time for the kill will be the square root of d squared plus h squared divided by v0. That's how many seconds he has to live. But you people are also quite smart. And you look at this diagram, and you said, no, no way. If this distance is d, then the speed to reach this point is v0 cosine alpha. In other words, the time that it takes for this object to reach this value of x, so for 26,100 MIT students, t-kill equals d divided by v0 cosine alpha. But what is the cosine of alpha? That is d divided by the square root of d squared plus h squared. So I can replace this cosine alpha by d divided by the square root. So I can replace this cosine alpha by d divided by the square root. and you and the monkey agree exactly on the amount of time that the monkey has to live. It better be that way, because this could not depend on which reference frame you work in, the falling reference frame, or, for that matter, the reference frame of 26,100. The monkey will be placed at about 3 meters above the table. We all know that it takes about 0.8 seconds. We have done many experiments at 3 meters. It takes about 0.8 seconds. So the whole thing will go very fast. We were going to put the monkey up there. I want you to first see the trajectory of that golf ball before we bring the monkey in. I mean, it is already so painful for this monkey. You don't want him to pre-experience what's going to happen. So we will do this in the absence of the monkey, and I will let you see what roughly the trajectory of that bullet will be. 3, 2, 1, 0. So it will hit somewhere here. That's that point P. So when you're going to see the drama in action, this is where the monkey will reach when the two hit each other. Now, you can imagine that this is a very painful day for the monkey, and I'm going to get the monkey. He's behind here, and I hope that you would pay some respect to Robert. His name is Robert, and it may take me a minute. Here is Robert. I thought it was appropriate to change for the occasion. I don't go on monkey hunts too often, but when I do it, I'd like to do it in style. Here is Robert, and we're going to put Robert up here. Robert has in his head a metal plate so that when we activate the electromagnet, that we can stick him on there, and when we take the current off, then Robert will fall. So this is the activation of the electromagnet. So here we go. I can see Robert is nervous. And you can't blame him. This is not the greatest day of his life. Oh, by the way, I want you to know, I mean, we are not cruel here. He's wearing a bulletproof vest. Oh boy, I can feel he's shaking all over his body. He's very nervous. Robert, don't let go yet. Oh, let me show you. It's important that you know that we have done everything we can to aim this gun as accurately as we can at Robert. Robert, don't let go yet. We got to first cock